Hi everybody, this video is going to start the Unit 9 and just a quick look at where we're going in Unit 9. This week we are doing 9.1 and 9.2 and then next week we'll have a quiz on those and then finish up with 9.3 and then 9.4 is putting these two together. That'll be on Friday and then the next day, early Monday, would be March 29th. We'll be taking a test on that, a quiz on that. We'll have time before the test to review. And then we'll take a quiz. Actually, that should say Tuesday. And then we're done for spring break. So the last day after this would just be a catch-up day, a make-up day. We might end up pushing this test back if we want to do it that way instead. So that's where we're going. This lesson today is about 9.1. A couple of some review terms. Intersecting lines just means they hit each other. So two lines that cross each other. They are in the same plane and they share a common point called the point of intersection. So line M and line L intersect each other at point A. Perpendicular lines, two lines that intersect at a right angle. And remember that when we talk about lines, we can either use a lowercase italic, italic basically letter, or we can use two letters with a line above them. But in this case, the main thing I want to talk about here is this symbol for perpendicular. So that symbol means perpendicular. So if I say line N is perpendicular to line P, I would write it out like this. All right, then the next two are a little bit longer. You might take a minute to pause it if you need to. Parallel lines, two lines that are in the same plane, but they never intersect. For instance, two lines on the floor, like two lines of tile maybe on the floor that are parallel to each other. Remember that the symbol for parallel is two lines. Like for instance, in this last one, I'll just take different letters. Let's say I have line A is parallel to line B. So it's those two straight up and down lines. That means parallel. And then we have this word named skew. I'm not sure if you've ever heard of skew lines before. I like this word. I think it's a fun word. And it's kind of a fun concept. They're lines that are not parallel, but they do not intersect. They never intersect each other, but they're not parallel. So for instance, a line going across the floor and a line going up and down the wall that don't hit each other. And so we're going to look at some examples of that, but that would be skew. And like I said, if you need to pause it here, you can do that. So now we're going to look at some examples. Think of each segment in the diagram as a part of a line. Which lines appear to fit the description? So something that's parallel to AB and contains point D. All of these are going to talk about point D, and that's why it's in the red there. So we're looking at that. We want something parallel to AB but contains D. Okay, do you see that this line would be parallel to AB but contains point D? So that's going to be, we're going to use, again, another way to write lines is to, this would be a segment, line segment we're calling it, line segment CD. Okay, the next question, perpendicular to AB, so again, keeping our focus on AB, but going through D, but it has to be perpendicular. That means it has to actually touch it. In order for it to be perpendicular, it has to actually touch it. So this line is going to be perpendicular to line AB, and it goes through D. Now, if we just look at the drawing, it doesn't look like that's a right angle, but in reality, like if this was a cube, a dice, something like that, you would know that that is perpendicular to it. So we're going to say that this is line AD. Okay, now this word skew, that was that one that I think was kind of an interesting word. Skew to AB and contains D. That means it's not parallel and it never hits it. So if we look at our choices, there are a lot of things that hit that line, but we need to come up with something that doesn't hit it. So I'm going to come over here to something that doesn't hit it, goes through D, but is not parallel. And so that's going to be this one, DH. Okay, a little bit of review. Name the planes that contain D and appear to be parallel to plane ABE. So we've been talking about lines so far, but planes can also be parallel to each other. So if we look at the plane that's like the right-hand side of this cube over here, that contains D, and it seems to be parallel to ABE. ABE, I'm going to show it here, is this plane here, and then we're focusing our attention, we're saying, well, this one is parallel to it. So we would call that CDH maybe. Remember, for a plane, we just use three letters, no lines on top or anything, just three letters of that plane. Okay, we're going to do something similar here in this diagram. Here we are really focusing our attention on the line TW, so I'll just highlight that so we have it, and the point V, which is back here. So our first one parallel to that line and contains V. I'm going to say it's this one back here, VU. Those are going to be parallel, and it does include the line V. Okay, perpendicular to TW and includes the point V. I need to get that V again. Perpendicular and contains that point. It does need to hit it. So it's going to be this one down here. It needs to hit the line. If it doesn't hit the line, it might be more skew than perpendicular. So we're going to say that one there. Okay, and that's our next question. Skew to TW and contains V. So we have actually, they've put some other lines in here, and we might have to use them, but we might not. So there are a lot of options on this one. Because they've drawn those extra lines in there. So remember, skew means it is not parallel, but it never hits it. And so I'm thinking like the first one that I see actually is SV here. So we could say segment SV, but there are others. Like for instance, VR. That's another one. It is not parallel, but it's not going to hit it. Let's see. Maybe, oh, it needs to go through V. So those are probably the only two that go through V that fit that description. All right, and then our last one is another plane. So it contains V and it appears to be parallel to TPQ. TPQ is the one, we can't really see it very well. It's the one over here on the right-hand side. So if we want a plane that's parallel, we're going to look at this plane right here. It includes V and it is parallel to that plane. So we're going to say VRS. And I called it VRS, but you could call it VWS, RVW. There's just any three letters that are in that plane. Okay, let's turn the page. We have a new word. It might be new to you. Maybe you've heard it before, but it's a transversal. A transversal is a line that cuts across two or more lines. So you might have these two lines, and then you have a transversal that cuts across both of them. So these are all pictures here, and the T stands for transversal. So this transversal is cutting across. Now, when that transversal cuts across, it creates a variety of angles, which we've numbered here 1 through 8. And each of these angles has certain relationships to each other. The corresponding angles are the ones that are in the same position, like the upper left and the upper left. So for instance, like angle 5 and angle 4, those are corresponding angles. You could also say angle 3 and angle 8 would be corresponding angles. I'm going to write some of these down, and I want you to also think about what would 6 be corresponding to and what would 1 be corresponding to. Okay, I wrote down angle 5 and angle 4 are corresponding angles. Angle 3 and angle 8 are corresponding angles. That little squiggle, that's my and sign. So however you make an and sign, that's what that is. Then over here I say angle 6 and what? And angle 1 and what? So angle 6, it corresponds to angle 2. And angle 1, it corresponds to angle 7. Again, they're in the same basic position, like lower left-hand corner, lower left-hand corner. Okay, then we have these things called alternate exterior angles. They are on the very outside opposite corners. So for instance, 5 and 8, those are alternate exterior angles. There's one more pair. Can you find the other pair? The other pair is going to include angle 6. It's alternate exterior. It has to be outside and on the other side of the transversal, so it's over here, angle 7. Okay, then we have alternate interior. Alternate interior, we have to go inside these inside lines, but they're alternate, so when they're on opposite sides. So for instance, angle 3 and angle 4 would be alternate interior angles. And then can you find the other two? So I wrote down angle 3 and angle 4. Those are alternate interior. Okay, the other two are angle 1 and angle 2. Those are the other two alternate interior. They're inside. That's what interior means, inside. They're like inside the two lines there, but they're alternate. They go on different sides. And then we have same side interior. So again, interior means go inside, but they're on the same side as each other. They're not alternate. They're on the same side. So angle 1 and angle 4 would be one of the pairs. Can you find the other pair? Okay, so I wrote down angle 1 and angle 4. Those are same side interior. Angle 3, and what would go with that? That would be angle 2. Okay, I'm writing down the first, so I'm going to focus our attention on this first set of them right here. And we're going to look at these and we're going to say, okay, if I know these, then which ones correspond over here? So I'm listing out angle 1, angle 2, angle 3, angle 4, and we're going to go through each one and decide which one goes with it. So angle 1, which angle goes with that? So that's going to be angle 5 because they're both in the the lower left-hand corner. So see if you can pause the video here and try to find what is the corresponding to angle 2, angle 3, and angle 4. Okay, so I came up with angle 2 goes with angle 6, angle 3 goes with angle 7, and angle 4 corresponds to angle 8. Alternate interior, those go on the interior of the angle and alternate sides of the transversal. Okay, so we're going to look at angle 4 and angle 3. So alternate interior, angle 4 would go with which other one? And think about which would go with angle 3. Pause the video here and see what you can come up with. Okay, angle 4 goes with angle 5, and angle 3 goes with angle 6. They have to like cross over. That's what alternate means. They cross over that line. All right, alternate exterior. Those are the outside ones, the very far outside corners. So that's like angle 1, what's it going to match with? And angle 2, what is it going to match with? So angle 1 goes with angle 8. That's the alternate exterior. We go to the other side and the far side. And then angle 2, it goes with angle 7. Same side interior, we're going to stick with 4 and 3 again, angle 4 and angle 3. And we're going to look at the same side on the interior. So what do they go with? Same side interior here would be angle 6. How about for angle 3? That's angle 5. Okay, this next section is really the same thing, the same exact thing. It's just that we rearrange our diagram. And so we're rearranging our diagram. So for the corresponding, I'm going to start here, 1, 2, 5, and 6. And I'm going to ask you, what do they correspond with in the other section? So go ahead and pause it here and see if you can fill out what those correspond to. Okay, you should have come up with angle 1 corresponds with angle 3, both in the upper left-hand corner. Angle 2 goes with angle 4. Angle 5 corresponds with angle 7. And angle 6 corresponds with angle 8. We just look at the same position, basically, of each one. All right, next question is alternate interior. So those are interior angles. So we'll focus our attention on angle 2 and angle 6, and we'll try to find what do they match with. So you can pause it here and decide what they go with. Okay, alternate interior means we go to the other side of the line, but we stay inside these two lines. So angle 2 and angle 7 are alternate interior, 3 and 6 are alternate interior. Alternate exterior, those are the outside, so that's like angle 1 and angle 5. Not that those don't go together, but we're looking for what does angle 1 go with and what does angle 5 go with. So we go to the very outside, we go to the other side of the line. See if you can come up with it. Okay, angle 1 goes with angle 8, exterior and alternate, and 5 and 4, again, alternate and exterior. Okay, remember that we've mixed it up. You can't go back and look at this drawing to come up with these answers because we mixed up the numbers, just so you know. Same side interior means inside the two lines, but on the same side of the transversal. So we're looking at what does 2 go with and what does 6 go with. So angle 2 and angle 3, those are same side interior. Angle 6 and angle 7, those are same side interior. Okay, that's the end of our lesson 9.1. We will do some more practice together in class.